The recording is being started. Okay, so good afternoon, everyone. Welcome to lecture 17 of the course on data structure and algorithm. So today is our first class after the Puja vacation. So before the vacation, in our last class, we discussed about stack, data structure, scheme, and its major operations like push and pop. We also have discussed about its algorithm development and program implementation in C language, to stack using array. Uh, so today we shall discuss about one application of stack, uh, that is um, Polish notation of arithmetic expressions for expression evaluation. So which is a very important application of stack. Okay, so you know, we are familiarized with algebraic expressions. We learned about expressions from our class 6 onwards, or class 7 or class 5 onwards. Okay, so we are given some algebraic expression, and we are learned about some rules or instructions, basically rules. Based on those rules, we can evaluate any algebraic expression. Okay, so the rule is very popularly named as Bodmas rule. All of you know that, right? So now if I supposed to use my computer to evaluate its expression, okay, so I have to also write a program on the computer. That means I have to provide some set of instructions and rules, okay, to my computer, to the computer, so that the computer is um, able to correctly evaluate that particular expression. So is my voice is clear to all of you, or is breaking, still breaking?
Yes, it's clear.
It's clear.
It's clear, sir.
Okay.
Yes, sir, clear.
Okay. So this is the thing. So compute, now we know, for example, if I want to evaluate, you know, if I want to evaluate 5 plus 3 minus 2, okay, so I can easily evaluate that thing because I know how to evaluate. What are the rules we have learned to express and to evaluate an expression. So 5 plus 3 minus 2. So you can do first plus. So 5 plus 3 becomes 8, and then you do the subtraction. 8 minus 2 equals 6. So this is something, a certain rule. Okay. So whereas if I do subtraction first, 5 plus 3 minus 2. So 3 minus 2 will give us 1, and then if you do 5 plus 1, it will give us a result of 6. So that matters. So the prioritization of the operators means, operator means arithmetic operators are popularly addition, subtraction, multiplication, division, and in computer, their modular division is there, exponentiation operator is there. Okay, so okay, is my voice now breaking?
No, sir, it's clear.
Okay, so some of the people are saying that voice is breaking, others are. So
No, sir,
let's
it's
see
clear.
from our own end, and let's see. Okay, okay, okay. Maybe due to the internet issue. So now, what I was telling, কি বলছিলাম? হ্যাঁ, okay. So the prioritization of the operators matters the most while performing evaluation of an expression. If I, so in that example, 5 plus 3 minus 2, if I perform subtraction first, result will be 6. If I perform addition first, result will be, oh, in that case results are same, plus minus, because those are something, I mean, plus and minus are having almost same priorities. But if you do some other expression evaluation where plus or minus and multiplication or division both are involved, So if you do plus minus first, multiplication or division later, then result will be different. And if you do multiplication and division first and then plus minus later, then result will be something else. Okay, so results are getting different. That means ambiguity. To remove the ambiguity, you have to set some sort of rules, that is priorities of or hierarchy orders of operators. So that for us, we have learned that thing, how to prioritize the operators, how to apply the prioritization of the operators. Okay, apply the bottommost rule on the expression and then evaluate the expression. But same thing we want to perform with the help of our computer. So we have to say we have to write some sort of program so that computer will be able to equivalently calculate the expression and produce us for the result. Okay. So now, so that is the problem. So how can this is possible for a computer? So in that case, to deal with this arithmetic expression evaluation, okay, computer needs to understand that sort of rules like bottommost rule, not exactly bottommost rule, but rules which are equivalent to bottommost rule. Those rules means what? We have to prioritize the operators, right? So how to make the computer understand the prioritization of the operators? So to come up with this issue, okay, um, you must actually convert a given arithmetic expression into such a sequence of symbols. You know, an expression consists of two things, operands and operators. A plus B. This is an expression. A, B are operands and plus is the operator. So this is an expression. Now you have to convert this expression into such a sequence which computer can understand easily to evaluate this expression. Okay. Now how to produce a meaningful sequence for the computer so that it can perform the evaluation. To address that issue, okay, to address this issue, one mathematician, computer scientist, who is a Polish mathematician. I'm sharing my screen. I hope all of you can see my screen.
Yes,
Can you
sir.
see my
Yes,
screen?
sir.
Okay. Right. So one Polish mathematician, Dan Lukasiewicz, okay, so introduced two popular Polish notations of expressions. Those are named as prefix notation and the other is postfix notation. Okay, and besides these two, we can talk about another notation which is known as infix notation. Okay, so I'm just giving an example for each of these cases so that you can understand. So first one is prefix. So you know for given some expression, let's say, okay, given some algebraic expression, let's say a plus b. Okay, so this is actually the infix notation. What do we mean by expression? We, human being, that is actually the infix notation. Okay, so in prefix notation, operator comes before, that is before operands. So in that case, a plus b will be written as plus ab. Okay, So A, B plus, these are nothing but characters. So you have to rearrange the characters in some sequence. So that is a meaningful sequence, which is known as prefix notation. A plus B is also a sequence of characters, operands and operators. A, B are operands, plus is the operator. So in some notation known as prefix notation, the operator comes before the operands. So plus AB means A or B are supposed to be added. That is the meaning of this prefix notation expression. Similarly, postfix notation, operator comes after, that is post, sorry for the noise, A plus B, it is like AB plus. Okay, and lastly, the infix notation, which we are used to see this expression. Operator comes in between operands. Okay, for example, A plus B. Okay, so now to evaluate expression, okay, we are familiarized with infix notation. We understand this kind of, but we don't know this prefix or postfix notation. So these are introduced for computers. Okay, so infix notation, if we apply a Bodmas rule on infix notation expression, we can evaluate the expression, right? Now what you have to do, suppose computer is given infix notation, because we understand infix notation, so we will give the infix notation of the expression to the computer, and computer has to convert that infix form into either prefix form or in postfix form for its evaluation. Computer has to evaluate the expression, right? So that means it is necessary to convert the infix expression to the equivalent postfix expression or the equivalent prefix conversion, prefix expression. Okay, so to evaluate expression, infix in to evaluate infix expression by a computer. Computer needs to convert the infix for either into postfix or into prefix form. Okay, so today our first discussion is on conversion of infix notation into the corresponding postfix form. Okay. 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 So that means we have to learn some sort of rules. Okay. And based on that rules, we have to implement the program using C language. Okay. So we have to understand the rules very, very clearly. Okay. Any question up to this? I guess no. Very easy topic. Okay, now for example, I'm giving one expression. Let's say one expression that is 4 Okay, so this is exponential. In some of the book, you will see that it is a dollar sign. So I'm here writing xi sign. So to represent this is as a exponentiation operator, e to the power. I mean to the power operator. Okay, so if I write 4 exponentiation operator 2, that means it is 4 square, 4 to the power of 2. That is the meaning. Okay, then star, then 3 minus 3, then plus 8 by 4 by 8 4 8 4 bracket plus 1. Yeah. Okay. Okay. So this is an expression in infix form. You
স্যার
know
ওই
the
ডলার সাইনটা, হ্যালো স্যার,
uh,
ওই ডলার সাইনটা মানেটা কি আগে বলুন?
exponentiation power.
ওকে
4 exponentiation 2 means 4 to the power of 2.
ওকে ওকে
Okay. And one thing I must mention here. So there are, few arithmetic operators which are involved in infix expression, like exponentiation operator, multiplication. This is division, plus, minus, addition, subtraction. Okay, bracket is also there. So bracket will be performed first. It is having highest priority, and then exponentiation will have the higher priority. Then multiplication, division will have the priority, and then plus minus will have the priority. Okay, so these are the hierarchical orders of the operators. So bracket first, then exponentiation, then star or division, they are having equal priorities. If you have learned also in case of C language this thing while evaluating expression, that you have also studied about operators and their hierarchical order. Okay, and you have seen that plus and minus comes under same priority. Okay, and star or division, multiplication, division comes under same priority. But still, if you are in some case in some dilemma, okay, which should be occurring first, plus or minus, or in between, dilemma between multiplication and division, so you can, that is something else, because if you perform multiplication first, division later, result could be something else. And if you perform division first and then multiplication, result can be something other. Okay, so there is also some ambiguity. So to overcome that dilemma or ambiguity, a concept which is called as associativity of operators, that is being applied. You have already studied in case of C language first year. So if you forget about that thing, associativity of operators, just revisit the concept. It's very easy to understand. So there are two types of associativities: left to right associativity of operator and right to left associativity of operator. Okay. Okay. So now here, So this is an expression starting from 4 ending with first bracket close. This is the expression. And what are the characters involved in this expression? If you traverse from left to right, and then the character is one by one character, I'm just reading out. First character is 4, then exponentiation, this, then 2, then star, then 3, then minus, then 3, the plus. All these are characters. 8 is a character. This slash, from slash, which is meaning that it's a division operator. So it's a character. 4 is a character, then division, first bracket, 1 plus 1, first bracket close. So each of these characters will be one by one scanned. Scanned means, okay, so you know what is the meaning of scanf, right? So scanning. So whenever you are entering the expression into the computer, so computer stores the expression. So each of the character is being scanned by the computer and is being stored somewhere. The question is where? It is storing the characters. The answer is stack. Okay, so first 4 is scanned, and then 4 will supposed to be stored in stack. So that is the usage of stack. Okay, then this exponentiation operator character will be scanned and will supposed to be stored in stack. So the question is, are all the characters scanned one by one from left to right end will be stored in the stack or no? My question is, are all the characters after scanning getting stored into the stack? They are
Stack.
supposed to be stored in the stack.
According to the precedence.
No, we are not talking about precedence yet. Okay, so from the left end to right end, excuse me. Hello, hello. So, from the left end to right end, each of the character will be scanned, and they are supposed to be stored in the stack. The question is, are all the characters after scanning be stored in the stack? The answer is clearly no. So there will be certain rules which will be applied on those characters scanned. Some characters will be stored in the stack, others will not be stored in the stack. Which characters will be stored in the stack, which characters will not be stored in the stack? Based on that, there is some sort of rule. So let's understand this. Okay, so ultimately you got the point. Okay, so characters are coming one after one, the characters are coming, and I am here to decide whether I want to store this character into the stack or not. So that is the case. Okay, so that's why we are writing, we are producing a column. So this is very important, very popular question. This is infix to postfix conversion, infix to prefix conversion, postfix to prefix conversion, or prefix to postfix conversion, or the vice versa. Yes, these are very important theoretical question. So type of character scanned, and then what type of character you are scanning, based on that what action the computer is taking. What is the rule to take some action? Okay. So first character. So suppose the character scanned is a space. Okay, the action should be taken is simply skipped, nothing to do at all about the space. So space is simply be ignored. Okay. So you know there are 128 number of standard characters. Okay. So out of which space is also a character. So then digit or alphabet. Okay, so digit, you know, 0 to 9, 10 digits are there. All those 10, numerical digits are also characters. And alphabets, there are 52 characters corresponding to 26 English alphabets, uppercase alphabets and lowercase alphabets. Okay, so 52 characters. So if the character scanned is a digit or alphabet, the action taken added to the target string pointed by T. So you have to construct a string. For example, let me, okay. Okay. So let me here P. So this is the target string where we will form the target string. Okay? So simply add it to the target string pointed by T. So what will happen in this case? So digit alphabet. Okay, we will talk about later with this example. Let us construct the rules first. Okay. Next, suppose the character scanned is opening first bracket, opening parenthesis. Okay. So what will happen? Simply it is added to the stack by calling push function. Okay. Next, closing bracket, closing parenthesis. So in that case, what will be happened? So operators present in the stack. Okay. So this is a target string. Also, you have to write a. So there is also a stack, right? So this is a target string. This may be a linked list or some array or some whatever character array, and this is simply a stack. So stack is containing some characters. Target string is also containing some characters. So see the first bracket, opening bracket. Okay. So if the character scanned is an open bracket, then it will be simply added to the stack. Okay. Next, if the character scanned is a closing bracket, then what will happen? So stack may contain some operators. So all the operators present in the stack will be retrieved. Okay, retrieved through a loop till a closing parenthesis is encountered. Okay, operators popped. Retrieve means using pop function you are retrieving one by one character operator. So operators popped are added to the target string. Okay. Okay. Next 5. If the character is an operator like dollar sign, okay, if an operator, I mean exponential operator, multiplication, division, plus or minus. So what will happen in that case? So in that case, firstly, the topmost element of stack is retrieved. Okay. Through a while loop, okay, the operators from stack, so we are giving a name to that operators, to those operators which are being retrieved from stack, SOPR, stack operator, for example, SOPR. So SOPR are compared with the operator scanned. Okay, COPR. So this is the operator being scanned, and the stack may contain some operators. So two kind of operators you are having. one operator is coming from the input device after scanning, and one operator is also already present in stack. So what will happen? So firstly, topmost element of the stack is retrieved. So through a while loop, what is, see, the operators from stack. So suppose stack is containing some operator. So that operator is retrieved or popped. That operator coming from stack, which is known as SOPR, and the operator just scanned from the input device, which is known as COPR, these will be compared simply as per the, in terms of their hierarchical order, in terms of their priorities, in terms of their priorities. Okay, priorities. So these are being compared. Now what will happen after comparison? So if the priority of SOPR is greater than or equal to the priority of COPR, this means SOPR is greater than equal to COPR means the priority of SOPR is greater than equal to COPR. For example, plus and minus, equality holds. For example, division and minus, division greater than equal to minus. Okay, so if SOPR is greater than equal to COPR, then two things you have to do. One is SOPR is added to the target string. Okay, and then COPR is added to the stack using push function. Okay, so this is the thing. But if SOPR is less than COPR, then you have to do what? SOPR is pushed back into stack using push function, and COPR is added to the target string. So two operators are compared, SOPR and COPR. Whichever is having the lower priority, that will be added to the target string, and the operator with higher priority will be simply go to the stack. That is the thing. Okay, so this is the complete set of conversion rules which we shall apply on this example, and we will produce the resultant postfix equivalent expression. Okay, and one thing, after applying these rules, you know, at the end, some of the operators may be still present in the stack, which should be added to the target string. Yes, one after another. After another using pop function. Okay, so let's try the example. Yeah. Okay, so first character scanned is 4. Okay, 4. So 4 is a digit or alphabet. This comes under rule number 2. So it will simply be added to the target string pointed by T. So sorry, 4. Okay. This target string is actually the final target string. The final form of this target string is actually your postfix expression. Okay. So here you will get the output, postfix expression output, target string. So 4. Then the character scanned is an exponential operator. That means it's an operator. So earlierly stack is empty, nothing is there. Okay, empty. So it's an operator. So firstly, topmost element of the stack is retrieved. So there is no such element. Okay, so that means SOPR is null, and this exponential operator is actually your COPR, character scanned. So definitely COPR is having higher priority. COPR exponential operator is being compared with nothing, so it is having a higher priority. So COPR is higher. That means this case is satisfied. So okay. An operator, firstly topmost element of stack is retrieved through a while loop. Okay, let me check once again. SOPR, COPR. SOPR is added to the target string, COPR added to the stack. Okay, wait a second. Let me check this. SOPR, COPR is higher. Exponentiation is higher. Exponentiation is higher. Okay. No, yes, I was actually silent for a time being. Okay, here is the wrong thing. It should be stack. Both the characters will be stacked, added to the stack. Only this is the correction. COPR is added to the stack. So now it's fine. So see, the character scanned is dollar sign means exponentiation operator. That is your COPR. Okay, COPR is your that exponentiation operator. Okay, and SOPR is nothing. It is empty. Okay, so these two empty character, which is nothing but a null, something kind of no character. So COPR is definitely having higher priority with compared to the nothing. Okay, so this case is satisfied. So we were right. The COPR is greater than SOPR. So this is correct. So what will happen? SOPR is nothing. So SOPR is pushed back into stack. So stack is empty. So this is not done. This is simply skipped, and then simply COPR is added to the stack. ठीक है? So as per the rule, just you apply the rule and follow the rules. So what will happen? So here what will happen? A dollar sign will be inserted. And in target string it was 4. So that is these are the contents of stack and target string. after successfully scanning 4 and exponentiation operator. Then comes 2. Then next operator is 2. A character is 2, and that is a digit or alphabet. So see, it is simply added to the target string pointed by 2. So what will happen? 4 and 2. Then for your understanding, we are giving a space. Otherwise, you will think that 4 2 means 42. So it's not like that. So next character is star. The star is an operator. Now we can understand better this functionality. So what is the character here? Star. COPR is star. So firstly, topmost element of stack is retrieved. What is the topmost element? Exponentiation operator. So it is popped through, it is retrieved through a while loop. The operators from stack. So only one operator is there. So while loop will be running for only one time. So COPR, SOPR is exponentiation operator, COPR is star. So this will be simply compared in terms of their priorities. And you know, this operator is having higher priority compared to star operator. So SOPR greater than equal to COPR. This case is satisfied. So SOPR is added to the target string. So what will happen? SOPR means that exponentiation operator will be added to the target string. So this was popped. So this was removed from the stack. It is popped. Compared. After comparing, that exponentiation operator goes to target string, and COPR star will be added to the stack. Okay. This is the thing. Next comes 3 digit alphabet. Simply it is going to target string. Next, minus. Again, rule number 5 will be applied. So now COPR is minus and SOPR is star. This will be compared, right? So this is popped. This is popped. Star. So star and minus will be compared. Star is having higher priority. So condition number 5B is satisfied. Condition number A is satisfied. SOPR is greater than equal to COPR. So SOPR will be simply added to the target string.
স্যার এটা স্টার হবে তো এটা
Star হবে
হ্যাঁ
আর একই হয়ে যাবে মাইনাস হলো next comes
yes sir
3 is digit added to the target string. Next comes plus. So plus and minus are being compared. So SOPR greater than equal to COPR again is satisfied. SOPR is minus. So SOPR will go to here. It is removed from here and plus goes to stack. Then 8 character is coming, which is a digit simply added to the target string. Then division operator comes. Okay, division operator comes. So now comparison between division and plus is happening. So COPR greater than SOPR, this condition is satisfied. So SOPR will be pushed back into the stack, means plus, and division will be simply going to target string.
ওখানে তো লেখা আছে সিওপিআর ও স্ট্যাকে পুশ হচ্ছে একদম লাস্ট লাইন
Oh, right, it's my mistake. Right. Okay. And actually a loop is running, while loop, and while loop will be running for only one time because before this division only one operator was there, plus. So then 4 is coming. 4 is a digit simply added to the target string. Then division operator comes. This COPR is division. Okay, now what happened? Firstly, topmost element of stack is retrieved. So division is retrieved. Okay, through a while loop, the operators from stack, that is SOPR is this division, COPR is this division. These are compared through a while loop. Okay, so we found that SOPR is greater than or equal to COPR. So SOPR means this division will go to target string. Okay, and this SOPR, COPR means division is added to the stack using push function. Okay, so I think one slight change we have to write in the rule, because what will happen then, this is the first iteration of the while loop. So let me remove this, then you will understand. So this is done. So this division goes to target string. So then what happened in the next while loop iteration, this plus will be retrieved. This is written, see, through a while loop, the operators from stack are compared. So first division was compared with COPR. After comparison, SOPR goes to this. Then next SOPR will be retrieved and compared with COPR. And you will find that COPR is of higher priority. So this condition is checked, satisfied. So SOPR is pushed back into the stack using push function, and COPR is also added to the stack. So this is happening. Okay. Let me check cross verify once. 8/4/, yeah, that's correct. Okay, so next, fast bracket start. Rule number 3, opening parenthesis is scanned. So simply it is added to the stack by calling push function. Okay, so next one, simply added to the target string. Then plus, so plus operator. So if it is a plus, so topmost element of the stack is retrieved. That is, first bracket parenthesis is retrieved, and through a while loop, the operators from stack are compared with the character. So we are not finding any operator. Okay? So we are finding a first bracket. So what will happen? The plus and first bracket is being compared. So definitely it's an operator. It is not an operator. So it is of higher priority. Simply SOPR is greater than or equal to COPR. COPR is greater than SOPR. So COPR will be, both of SOPR and COPR will be pushed back into the stack. So simply what will happen? So after first bracket start, paths will be added. Okay. Next is 1. 1 means it will be simply added to the target string. Target string, and then interesting thing is closing bracket. So closing bracket is scanned. Now what will happen? See, operators present in the stack are retrieved through a loop till a closing parenthesis is inquired. I think this should be open. This should be open. But open parenthesis, opening parenthesis is encountered. So operators popped are added to the string. So what is happening? See, the COPR is a closing bracket. Okay, so a loop will be started, and one by one operators will be popped. So first plus will be popped. Okay, so this popped plus operator will be added to the target string. So after 1 1, it should be plus. Okay. Next, what is happening? Open parenthesis encountered. That means this loop is terminated. The loop will be continued till a opening parenthesis is encountered. Okay. So it is terminated. It is terminated. That's fine. So all the entire these rules is being applied and the process is completed. And next, what is happening here? The final note at the end. So after this is the situation. Stack is containing this and target string is containing this. And for your understanding, I mean to say that after the completion of the conversion, stack should be empty. It should not contain any character. But still, you see here, stack is still containing some characters, which are nothing but operators. So from this scenario, you have one thing you have noticed, note that stack contains only the operators. Stack does not contain any character other than operator. And yes, other than operator means first bracket or close bracket. This much stack can store. Okay. So at the end, some of the operators may still be present in the stack, which should be added to the target string. So one by one character operator from the stack will be popped. So first division will be popped and added to the target string, and then so it is removed. Then plus is popped and added to the target string. So stack finally becomes empty, which should be the scenario. So now the process is completed. This expression is your postfix expression. Converted postfix expression. Okay. Any question up to this? You can ask me. So it's just a matter of practice. You have to remember the rules and apply and practice with some examples. Infix to postfix conversion.
স্যার বলছিলাম যে স্ট্যাকে তো ওপেন ব্র্যাকেট আর ক্লোজ প্যারেনথেসিস এই দুটো তো স্ট্যাকে ছিল, তো ওগুলো তো টার্গেট স্ট্রিং এও যাচ্ছে না, তো ওগুলো কোথায় যাচ্ছে?
ওগুলো simply ignored হয়ে যাচ্ছে because actually in the next class probably I will talk about some theoretical aspects of postfix and prefix expressions. So I will talk about the salient features of prefix and postfix expressions. So one of the feature of postfix and prefix expression is it does not contain any parenthesis. It doesn't matter in case of postfix expression.
ওকে স্যার, ওকে স্যার।
Or in prefix expression. Okay, so that's why it is being simply ignored. But it is very important thing, first bracket and close bracket. Okay, so because on that basis, you know, certain rules are being applied. So that's why they are important. Any other question? এটা অ্যাপ্লাই করলেই তোমার পোস্টফিক্সে অর প্রিফিক্স এক্সপ্রেশনে কনভার্ট হয়ে যাবে আর ইভালুয়েশনও হয়ে যাবে।
আচ্ছা স্যার, আর একটা জিনিস, যদি অ্যাট লাস্ট স্ট্যাকে যদি কোনো অপারেটর বেঁচে থাকে, তো দোজ অপারেটরস আর বিং অ্যাডেড টু দ্য এন্ড অফ দ্য স্ট্রিং, রাইট?
হ্যাঁ, ওয়ান
টার্গেট স্ট্রিং এর শেষে।
and add.
আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে।
Because you see here it was, এই জায়গাটা প্রচন্ড কেয়ারফুলি করতে হবে, বিকজ তাড়াহুড়ো যদি করতে চাও তাহলে সিলি মিস্টেক হবেই হবে আর পুরো ভুল হবে। তো এখানে দেখো স্ট্যাকের কন্টেন্ট এইভাবে ছিল, প্লাস এন্ড দেন ডিভিশন। সো ফার্স্ট, এন্ড দিস ইজ আ স্ট্যাক, সো ফার্স্ট ইউ হ্যাভ টু pop this and add it to the target string. Then you have to, so this is removed, right? Then only plus is there, so you have to pop out this and add to the target string. এখানে লেফট টু রাইট প্লাস ডিভিশন ছিল, এখানে দেখো ডিভিশন প্লাস হয়ে গেছে, so that matters.
ওখানে স্যার রাইট থেকে পপ হবে, পপিং আউট শুরু হবে রাইট সাইড থেকে।
আমরা স্ট্যাকে যেরকম স্ট্যাক থেকে তো যেখান থেকে খুশি
Yes,
তো
sir.
pop করতে পারো না, ওখান থেকে পপ করবে, টার্গেট স্ট্রিং এ অ্যাড করবে। টার্গেট স্ট্রিং এ অ্যাড করা মানে অ্যাপেন্ড হচ্ছে বেসিক্যালি। এটা যদি তুমি অ্যাকচুয়ালি
Yes,
লিংক,
sir.
if you think target string to be a linked list, then you are just appending the characters. Or if you think it's
Yes,
a
sir. Yes,
character
sir.
array, only at the end of the string you are adding the characters one after another. Okay.
Okay, sir. ঠিক আছে।
And there is another actually application. We will actually talk about another application, an application of a linked list. Okay, we skipped for that part for the time being. It will come in some later lecture. That application of linked list, as an application of linked list, we will do actually arithmetic operation. I mean evaluation of arithmetic operation. More specifically, I meant to say polynomial. Okay, so linked list can be used to store a polynomial. So if we, polynomial means x square plus bs plus c, quadratic polynomial, like that. So any sort of any degree, polynomial of any degree. Okay, so if a polynomial can be stored or represented by a linked list or stored in a linked list, so then what will happen? We can perform arithmetic operation on the polynomials. Like, so is it possible to perform polynomial addition? Subtraction is not a big deal because subtraction is a negative addition. And also it is possible to perform polynomial multiplication. Okay, so we will do that. So polynomial addition, polynomial multiplication using linked list. So there we will understand how linked list can be used to store some polynomial. Polynomial means then you will understand, okay, this target string you can form using a linked list or using a array, not a problem. Whereas I mean linked list could be better because the length of the target string is not defined, so you can't actually define in the top of the program what will be the size of the array if you take it as an array. So better it will take as a linked list, and you append one after one by one node. Those node are nothing but storing a single character. That's it. Okay.
Okay, sir.
Any other question? So topic is very easy. Just you have to remember the rules and apply the rules. Just. Okay, so we are stopping the lecture here. Thank you for listening. So see you in the next class. No quiz, short quiz today. So it will be given tomorrow.